so let's go ahead and resume where we were yesterday, kind of going through just some of the notes about polynomials, a little bit about the notation, and then today we'll again have a pretty good chunk of work time. So on the notes yesterday, I was going to start off on example 3 here, where it says, let's go ahead and sketch the transformations of the parent quartic, determine the end behavior of the graph, as well as number the list of intercepts and extrema. So what does an x to the fourth look like? What did we say yesterday at fourth degree look like? Does it look like a parabola, but what was special about it? Is it kind of had that little bit of a flattened bottom, didn't it? It didn't have that nice smooth curve. It's actually kind of almost hard for me to graph it because it just looks kind of just weird, like I'm messing up my quadratic. But what do you know based on last chapter, what should have happened to that parent function? See that x minus 3? What is that going to do to that function? It's going to move it to the right 3 and down 2. Is it that same thing? It is. So again, what's going to happen is my vertex, which is, you know, really not technically a vertex because that's a term that we use for quadratics, but it's going to look something like this. And let's kind of talk about what we have. Now that's a very, very basic sketch. Nothing specific, nothing all that careful. But can you tell me what the end behavior would be? Let's practice that. So the end behavior would be the limit as x goes to infinity of f. Where is the graph going as I try to approach infinity? Positive infinity. And then what happens as I try to approach negative infinity? It should also be infinity. Why were these in agreement? Because the power is even. Now, how about this? How many x-intercepts are there? I personally prefer to use the term roots, but roots, intercepts, zeros all say the same thing. How many roots should this thing have? Should have 2. How many extrema? Now, Michael is gone. Who can tell me what extrema is? Yeah, maxes and mins, right? Now, by the way, we said there were 2 roots. Can anybody tell me how could I actually find where those roots are? A root is specifically where the graph hits what value? 0. How would you go about solving that? Not plug in 0. That would actually, if I plugged in 0, that would actually tell me the y-intercept up here. How would I solve that? Get x by itself. What would you do first? Move that 2. Take the root of both sides. Oh, yuck. So what are the 2 roots? Oh, I forgot something. There should have been a plus or minus. So I need to move that 3 across. It would be 3 plus or minus the 4th root of 2, which is gross, but it's what it is. No big deal. Okay. I'm going to choose to skip over this one because I want to get you where I'm going. So the only thing about this dude right here is, I suppose, is that it kind of has the same feel and it goes this way, but what's the important part about that is how many roots would it have? It has no roots. How about extrema? Still has 1. And I'm not going to really do a whole lot with that problem because I just kind of wanted to make sure you understand that, well, they always have roots. And I got to say, when I was a kid, you know, high school kid, I did not really always understand why my teachers kept harping on solving problems equal to 0. Why do we always solve all these dang problems equal to 0? Well, can you take any question and move it around and make it a problem equal to 0? So is every problem equivalent to a question that said equal to 0? So if you're really good at solving things equal to 0, what can you solve? You can solve every problem. So really that's just the simplest way, and if we all do it the same way, it just means we have some good strategies. Okay, letter C, we're going to just pop into this. This is actually going to start establishing where we're going to be going for the rest of this unit. So when you look at that one, I think everybody understands right now, like the one above, its end behavior as I go to infinity is still infinity, as is its end behavior to negative infinity. Why are they both infinite? It's because the leading coefficient is positive. And what is the exponent of the graph? What is the power of this thing? Is it's a fourth, right? So I know that when I graph this thing, it's going to be up on the left and up on the right. But my general shape, though, I can do a little bit with it. What do you guys notice that these two things have in common? Look at that. 2x to the fourth, 8x squared. What do they have in common? They have a 2 and they have an x squared, don't they? So what we're going to do, and in this particular chapter that we have coming up, guys, this is going to be really, really significant. Taking a look at a problem in standard form and writing it in factored form, because if I can ever factor it, my life gets much, much, much better. And then I can answer those questions. Keep in mind, x squared minus 4 is x plus and x minus 2, right? So help me out. Where are my roots now? This is easy. 2 is a root. Negative 2 is a root. And something else is a root. 0. Oh, by the way, that tells you how many roots did we have? 3. Wait a minute. Wasn't this a fourth degree? It's a fourth degree. Shouldn't there be 4 roots? The rule said it was, what was the rule? The rule was that not that it had 4, it's that it had at most 4 from yesterday. We talked about this, right? At most 4. So what did it have? At 3. By the way, I'd actually argue that it has 4. It has 1 there, and it actually has a double root right there, doesn't it? Isn't that x times x? So it has a root at 0 and another root at 0, so it's like a double root. So tell me how this is going to work. How is it going to pass through out here at negative 2? What does it have to look like? What's the power on that thing? It's a line. It was above, which means it's going to have to come down this way, isn't it? The root at positive 2 is going to have to go like that, but what's going to happen at 0? Specifically, x squared. What does it have to look like if it's squared? A little parabola. Now, should the parabola go up or should the parabola go down? Look at the little pieces. You can tell it has to go down, can't you? So it's going to have some little look like this. So what's it going to have to do then to fill? What do I have to do to make this work? It better switch around and come back up, right? So this sucker is going to be a W, isn't it? So how many extrema does it have? Be careful on this one. This one has 3. It had 2 mins and a max. So extrema, it had a total of 3. So let me see. Can you guys factor this sucker out and see if you could sketch that one for me? Letter D. Go ahead and get yourself some nice sets of factors. It's actually rigged up to be really gentle. Put your end behavior information on it. And let's see what we can do. What's the power? You guys, by it's a fourth degree viewer, pop it out. Leading coefficient, positive or negative? What does that tell you? Thank you. Down, right? That thing is coming down on the side. By the way, I draw those arrows just as a mental note to myself. Not that I'm actually going to try to connect those specific arrows. Who can factor out x squared minus 1 for me? That's sort of like a nice little soft pitch. What x squared minus 1? That's like the nicest factor you're ever going to get. What is it? Stephanie's smiling. What is it? Sweet. So we've got a couple of roots, one at 1 and one at -1. Cool. Who's got x squared minus 16? Another soft pitch. I loved these when I was in high school. Like, sweet, you're not going to make me think hard. What is x squared minus 16? Sweet. By the way, if your teacher does that, it's because they're being very kind to you. They didn't make you think super duper hard. Okay, so how does it have to pass through? Out here, this leftmost one, if it's down over here, what power do I have here? That is a terrible looking four. How should it come through? Should it come from the bottom up or the top down? Bottom up, in what kind of shape? A line or a U or a curve? I gotcha. Should just be a line. Now, why is it a line, everybody? What's the degree on it? It's a first degree. So it's going to come up, right? Jolene, what's going to have to happen at -1 right here? Just come back down like a line. What's going to have to happen, Cooper, over here at 1? Up or down? It's going to have to go back up, isn't it? And then come back down. It has to be that kind of shape. Can I play connect the dots now? Yeah, it should be able to kind of like, oh, fine. It's going to come up like this, come down like this, go back up like this, and go down like that. Now, again, the fact that I didn't do this on graph paper means that my spacing is a little bit wonky, but it's all right. So we talked through all of this yesterday, so I'm not going to worry too much about that portion of it. I want to kind of move into another little piece, but we also have talked about this as well. Now you're going to notice all this dotted stuff in the middle, because ultimately we don't know what all of those are for every value, but if you have an odd, it's going to look like one of these, and an evens. Why is it dotted? Yeah, it may or may not have that many bumps. We may not know how high up those bumps are. That's why yesterday I said don't even worry about the axis at all. Just kind of just give me a general concept of the shape. And so in behavior, I don't think this is going to be a particularly hard one for you guys. What's going to happen, I feel like this has actually landed this plane okay. What are these values? If you have -2x to the fourth, what is the in behavior? This is a really big deal in this one. What are they? They're both negative what? They're both going down. How about on G right here? What happens if I go to infinity? And I need to change that. Just realized that we switched letters here, didn't we? So what happens as t goes to infinity on g of t, or as t goes to -infinity on g of t? Now something is a little different. This is a positive 2t to the 7th. How's it going to go as I go to infinity? It's going to go up. Isn't this easy? What's going to happen on the left side? Why? It's odd, and they always disagree. So when you look at letter B, although I don't think I'm going to take the time to write extensively every single stinking one out, look at that. Somebody messed it up. What's wrong with the way letter B was phrased? It's out of order. Which value should have been first? Ooh, that should have been first. So what would that tell me about it? That would tell me that the limit as I approach infinity of p should be the same as if I approach negative infinity of p, and they should both be down, shouldn't they? Now, by the way, do you notice I just messed with the notation a little teeny bit? Because I'm just saying, hey, the answer to this one is the answer to this one is the answer negative infinity. You guys cool with that? I could write it twice, but it seemed like it was just more efficient. And how about the last one, D? Who's the power player in that story? 2t to the 7th. What's the answer then to letter D? Isn't it the same as C? So what's the difference between these two? Well, yeah, it's the dots in the middle. They're both going to have basically this view right here. It's just one of them's just going to have a simple S curve, and the other one's probably going to have a little hump and stuff in the middle, a little bit of a wave in the middle. So I'm just going to write same as C. I think we established this next one pretty well yesterday. Is that a polynomial of degree n can have as many as n zeros, but it has at most n minus 1 extrema. That's a really, really important one to make sure that you have down. Does that mean that you have to have n and you have to have n minus 1? I think we've established that as well, that that's a maximum value. Now, there's a couple things that I wanted to get to today with you guys. Are you guys okay with this portion right here? If somebody asked you to graph that, you notice that I'm kind of skipping around a little teeny bit because we've actually established some of the big writing. If you need to kind of review that, you can. But ultimately, what is the power of this crazy thing? Count them up. I got 1, 2, 3, 4, 5, 6, 7, 8. This is a 9th. And the leading coefficient is negative. So what does that mean? Is it's going to be down this way and it's going to be up that way, isn't it? Do we know that? So let's go back. What's the furthest root to the left? Okay, so negative 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. So I got that one, right? There's one at 3. There's one at negative 2. One at negative 5, one at 0. Did I miss one? And one at 6. Did I get them all? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So this is really what I want you guys to be able to do in the particular unit that we're in. Is I would like you to be able to take something that is in this pretty little form right here and sketch it. So, Dakota, look at negative 5. What should jump out at you at negative 5? There's something really special about that one. I gave you the hardest one. It's the only one that has an exponent on it, isn't it? So what should happen?
Oh, it's squared.
It's squared. So what's going to happen when I graph it? It'll make a U. So it's going to make, now why did I make that U up? Because look right there. That thing is going up, isn't it? It has to. So I know the graph is going to go like this. Now, where is it going to go from here on? It's going to go to infinity. So when I go to my calculator and I say, I want to see what this thing looks like, because I would like to do that in a second. I don't even bother to look, because you know how fast this thing goes to infinity? It's ripping quick. A 5th degree polynomial, actually this is a 9th, wasn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to go up really fast. Okay, so somebody tell me what's going to happen when it reaches this one, the one at negative 2. How's it going to go through at negative 2? It's going to be an S curve. Now, is it an S curve going from the bottom to the top or the top to the bottom? It has to be the top to the bottom, so it's going to have this kind of flavor, right? How about at 0? What's it going to do at 0? Straight line. Going down to up or up to down? It's going to be down to up. And then at, let's see, this one was 3. A little parabola again. So what's going to happen? An up parabola. And last but not least, what happened at 6? It's a line. Okay. So could you guys kind of try, what's going to happen in between these two that I don't know? What has to be in there? A maximum. There has to be one, right? Now, do we know how high that maximum is? No clue. What has to be in between these two? A minimum. Somewhere down here, and then another maximum, and then another maximum. Now, when I put all that together, it should look something like that. But what I don't know is how high that maximum is, nor do I know how low those minimums are going to be. So let's see if we could actually sketch that. And I guess I probably should have planned this one and had it all typed in advance. I just didn't get to it. But this is what we've got here. So let's see what we got. So we had y equals negative 5x. We've got x minus 3 squared. I've got x plus 2 cubed. And I've got x plus 5 squared. Good golly, this thing goes from forever, doesn't it? And x minus, well, before I do that, I'm going to hold off for a second. Let's figure out what window we should pick. What's the lowest root I had? Because this is what I want you guys to learn how to do. What's the lowest root to the left side? This is negative 5, right? So personally, I go to negative 6 because I know once it passes that last root, it's going to get out of Dodge really, really fast. What's going to happen on the far right? What's the last root on the far right? 6. So what should I give it? Let's give it to 7. Now, the other problem that I have with this thing is down here. These numbers get stupid big because raise something to the 9th power. You guys know what 2 to the 9th power is? And 2 is a pretty small number. It's like 500 and something. So it is pretty normal that you're going to get really large numbers in here. So I personally usually start with kind of big values, like 500, maybe 1,000, because I don't know how big it's going to be, but you can always shrink it down this way a little bit if you need to. So let's see if I did enough to give it what I wanted, because it was supposed to be minus 6. Did I give it enough room on the high and the low side? No, man, that thing was going crazy, isn't it? But what you can see, do you see how it's coming through like lines in some of these places? But do you see the little S-curve? It's a little faint right there. It's hard to see, but it is definitely there. Man, this one looks like it's going absolutely crazy. I wonder if even 1,500 is enough. Jiminy Christmas, that thing is going, wow. Okay, I'm not going to find the top and bottom of that bad boy because this is just like way up there. This must be probably 10,000 or even better than that. So I don't think I want to sit there and try to fiddle with it until it happens. But trust me, you can mess with it until you get there. All right, let's move on. All right, so one of the problems with the unit that we're going to get to, and this is actually something that's going to start out being more of a focus over the next couple of days, is if you get that pretty form that I showed you in the last one, it was super easy. But this thing is called what form? This one is called standard form. And honestly, standard form sucks. Where are the roots? You look at it and you're like, I got nothing. So that's why in the particular unit we're in, we're going to go crazy on factoring. We're going to learn a whole bunch of new factoring techniques, which is why I'm going to basically do this today. So what's the first thing that you notice? I'm kind of giving you building blocks of factoring today. And I know you did a bunch of factoring in Algebra 2, but I'm going to add a little bit. What's the first step to factoring every time? What do they have in common? The greatest common factor. And by the way, as a rule, I would tell you, always pull negatives. If the leading coefficient is negative, pull that as well as a common value, okay? So what do you notice that they all share? They have a negative and they have an x squared. Now, right away, as soon as you say that, make sure I did that all right. I think I did. What do you know already better happen in this graph? Look at x squared. What is the root of that? This thing better have a little bump at 0, isn't it? I also know it's a 4th degree, so it's going down on both sides, isn't it? Now this graph, this doesn't even say to graph it. I just want to find the roots. I guess we could sketch it. So how about that? Let's see if you guys can remember how to factor that. 2x squared plus x minus 3. I do need you to get into the habit of being able to factor quadratics pretty quickly. So what's the magic? 2x and x. Okay, now that's if it's factorable. Now, if it's not factorable, we could go quadratic formula or we could complete the square, but it's got to be that. And what's the only thing that could give me 3? 3 and 1. So you're either going to put a 3 and a 1 or a 3 and a 1. Does the 3 go first or the 3 go second? It has to go first. Otherwise, if the 3 was out here, I'd get a 6 and I'd be in trouble. So I'm going to put a 3 here and a 1 there. So how does a 2 and a 3 make 1? 2x and a 3x make 1x. They have a negative on which one? On the 1. So I now know that this graph is going down left, it's going down right, it has a bump there, negative 3/2, positive 1. The graph has to have this kind of shape like this. And that's literally all I want you guys to do, is just be able to quickly go through that process and do that. You guys all right so far? We'll try to finish this up quickly so we can get to what we're doing. Number 9 is one of the biggest things that I was looking for when I got here. And I actually went and talked to the Algebra 2 teachers to find out if they did this, and I was told no. Now, look for GCFs, everybody. Bummer. Do you notice that? I got nothing. What the heck do I do? Well, there's a hint here. It says factor by grouping, and that's probably something you have not had a chance to do. According to the Algebra 2 teachers that I talked to, they didn't do this. So this is a special thing that works specifically if you have an even number of terms, okay? Do I have an even number of terms? So watch, this is so goofy. It's just like if you've never done it, it works. It doesn't work all the time either, by the way. But what I do is I break it up into 2 chunks. That one and this one. That's why I said even, because I want the 2 chunks to be the same size. And now let's play the same game that we said. The first step is factoring, looking for the greatest common factor. What do those 2 things have in common? They have an m squared in it. Now, if I factored out that m squared, I would have left an m minus 2. Now, here's the cool thing. You see that m minus 2 that I had? I'm hoping that this one over here also has an m minus 2. Does it? Look carefully. Yes, I know some of you are shaking your head. You're seeing it. What has to go in front so that I still have a negative 4m and a plus 8? A negative 4 would work. So what I have is m squared minus 4 times m minus 2. Now again, that feels awkward, but you notice how both of these chunks have an m minus 2 in common? And so if I took the m and the minus 2 out, I still have that m squared minus 4, which is really kind of counterintuitive because something cool happens. What's m squared minus 4? M plus 2, m minus 2, and we still had the m minus 2 from there, didn't we? Holy smokes, what should I do with that since I got m minus 2 and I got another m minus 2? Ooh, that should be squared. So I have this m plus 2, I have this m minus 2 squared. Hey, it's a cubic, right? Leading coefficient is positive. How does it have to end to the right? It has to end up. It had to start down. It had roots at negative 2 and positive 2. So help me out. What's going to happen as it passes through negative 2, everybody? It's going to, What's going to happen as it goes through this one right here? Little line, boom, right? What's going to happen over here at positive 2? A little bumpy, right? It's going to go like that. What's left? What has to be in the middle somewhere? Little maximum, boom. I don't really know how tall it's going to be, but I think we're good. Now, I'm going to go ahead and skip a little bit all the way to number 12 and 13 because I want to make sure that we have enough time to do what I want you to do today, where you're actually not just sitting and passively listening. I really am trying to be careful about that. So let's see if you guys can help me. I'll probably come back to a couple of the pieces that we didn't do tomorrow. But can you help me write the equation of this crazy thing? Somebody graphed it for me. Who's got a piece? Let's just go left to right. Somebody tell me what I would write to represent that portion of the graph. X plus 5? Y squared? Because there's a parabola. Okay. How about this next piece? What do you notice? It's a cube, so x plus 2 cubed. Okay. How about the next one? What do you see right there in that central place? It's a line, so what's its power? Well, I usually just, if there's an x, I usually throw it in the front. You know, that's just what I do. If you put an x right here, would it be okay? Yeah. If you wrote x minus 0, is that okay? Technically, but it looks kind of goofy, doesn't it? Right, x minus 0. How about the next one? What do you see about here at 3? That looks like a line, so I'm going to write x what? Minus 3. And how about the last one? I think that's x minus 6. Now, the one thing that a lot of people don't remember is, what's the power of this thing? Let's count it up, and let's look at the positives and negatives. I got 1, 2, 3, 4, 5, 6, 7, 8. My leading coefficient, as I put it down, is what? Positive, isn't it? That's going to bug some of you. What would happen if I put a bigger number in front? What happens if you throw a number in front of a polynomial? Doesn't it just make it taller or shorter? So would A change the shape of the graph? It didn't make it taller or shorter, but would it actually make all of these things look like what they look right now? But I know no matter what, that leading coefficient has to be what? How about this number 13? What do you notice about it? What does the leading coefficient have to be in that one? It's odd, that's true, but it has to be a negative. Why do I know it has to be negative? Because it ends down, doesn't it? By the way, I really don't like this. If I was doing this myself, I would just oh my gosh, this is awful. The graphs never come off. This thing has to go like this. I mean, I guarantee you, you will never find a graph that comes splayed out to the side. Once it crosses its last root, it goes to infinity in a hot minute. It goes really fast. But whatever. I didn't want to rewrite the whole thing over that. So I think everybody's got that we have a root at 4, right? What kind of root do you think it should be? Just regular? How about at negative 2 here? I think it's regular. How about at 0? It's squared. How about at 1, 2, 3? This is kind of what he was trying to get at. You kind of see he's trying to do, I think he was trying to make an S-curve and just kind of did a poor job of it, but 1, 2, 3. I'm not going to be throwing too many stones here. But here's the thing. This was h of x, right? What do you guys know about a this time? A is what? A is negative. Why do you know a is negative? Because it ends down. Oh, this is so mean. And yes, I will do this to you on your next test. He said this curve went through 1, 2. That means it's not a general solution. It's going to be a particular solution. we can find out the very specific graph that does this. So it says that if I plug in 1 for x, what does y become? It becomes 2. So let's see what happens. Let's plug in 2 for y. Let's plug in 1 for x. Is that going to be hard to find out what that specific a value is? What happened on the right side? I've got 5 times 3 times, yuck. -8. Ew. What's 5 times 3 times -8? I got -120. What does that make a? Negative what? How do you get this a by itself? Divide. You're on the right track. What is a? There you go. You had it. So in our case, if you had this, now why would somebody put a weird coefficient like that? Why would anybody in their right mind make a leading coefficient like -1/160? Or -1/60, I meant. Remember that last problem when I was trying to zoom in on it and I was like, it was up at the 10,000? Why would you give a leading coefficient of like 1/60th? What's it? It's just going to shorten it down to you can actually see it. So on your test, it's pretty common. If I have like an 8th degree polynomial, I'll have a leading coefficient of like 1/24th. And you might think that that's to be mean. It's not. It's so that it actually won't go up to have peaks at 25,000. It's going to have a peak at like 60. Something a little bit more reasonable. So this is a pretty common thing to do. So that's kind of where I wanted to stop today. I'll polish a couple little things off tomorrow, but I wanted to make sure you got a little bit of work to do today. So we're going to do what's called symbolic polynomials today. And I liked it because I'll admit it, I stole this from somebody else, but I also modified it too. So this graph G right here, somebody tell me something you know about G right away. It's probably a 4th degree. Would you guys buy that? Why do you think it's a 4th degree? What are some of the hints? 1, it definitely is going up field goal time, right? I see 4 roots. That also leads me. Could it be a 6th degree? It could. I'm not really 100% certain. But you know for sure that it couldn't be a cubic, could it? Because it has too many roots for a cubic. Also, you know, a couple other reasons. But what's going to happen in here is I gave you a bunch of possible equations for it. And one of them, or more, are legit. And what you have to do is, if you circle no, I need you to say why you're saying no. So like, for example, in A, what do you notice? I have a 4th degree. What do you guys think? Does that seem legit? Does A look good? Stephanie, why are you shaking your head? Because the leading coefficient is negative, and that can't be true because if it was negative, what would the end behavior be? It would be down. So you're going to say no, and I would just say the end behavior is incorrect. Follow? So you're going to say why you know it's not true. And as you go through this thing, you're going to go through a series of equations and figure out which one could be and which one can't be. Notice that in most of the cases, I'm not even worried about that axis. And unfortunately, something irritating happened. And when I printed it, it threw letter D onto the wrong page, which just totally frosts me. People online, I actually fixed it before I posted it electronically for you guys. But D is on the wrong page. So that's a possible answer. So if you're like, nothing works, well, D's on the wrong page, sorry. And the last one is I gave you a bunch of these, and I really like this for the test. That's a hint. I gave you a whole bunch of them, and then I gave you a whole bunch of equations, and no, they don't match. There's 6 graphs, and there's 9 equations, which means I guess there's a few that won't get used, right? You're going to try to match them up, and see who matches with who and all of that kind of stuff. And I think it's a pretty good little point of conversation for you guys to have. And so that's what we're working on today. And so there we go. Now you didn't get this already, right? I don't think I had this out for you. So 1, 2, 3. You absolutely can work together and discuss, because actually I love to hear you guys talk about the math. Because these are thinking questions. 2, 3, 4. There we go. All right, so sorry I forgot to stop the video on that one, but we're just going to be working for a little bit and kind of just see how that all plays out. Let me know if you need help. All right, bye-bye.